Okay, so as in the last video we have discussed about the electric dipole. What was it? It was a simple system of electromagnetic in which a pair of opposite charges, which means Q plus and Q negative, pair of opposite charges, which means if a charge is positive then another charge will be negative. So a pair of magnitude of opposite charges are placed at a distance from each other. So they are placed at a distance from each other is what we call the electric dipole. And we have basically seen the formula for finding the electric dipole as well. And of course there was the product of magnitude of the charges, magnitude of the opposite pair of charges, right? As I've already told you, positive and negative, right? So this is the product of magnitude of opposite pair of charges and the displacement gives us what? Gives us electric dipole. And electric dipole is represented by P, of course. Now let me tell you its unit, how we're gonna drive the unit for it. But before going towards driving a unit, I want to tell you guys another definition for the electric dipole as well. So again, today's topic would gonna be very important in terms of MCQs, multiple choice questions, right? Questions. Okay, so what is an other definition of the electric dipole is electric dipole is a product of magnitude of opposite pair of charges, magnitude of opposite pair of charges, and displacement between the charges, right? And displacement between the charges. Is what we call the electric dipole. So here we have got our another definition for the electric dipole as well. What it is basically a product of the magnitude of opposite pair of charges, which means Q plus and Q negative, opposite pair of charges, and the displacement or the distance they are placed at from each other, the displacement between the charges. So let me write this in the mathematical form. Mathematically how it can be written, as P is equal to, because we know that electric dipole is denoted by P. It is the magnitude of the opposite pair of charges and the displacement. Alright, so this is the formula, as we have discussed about this yesterday as well. This is the formula. But now we want our SI unit for the electric dipole, right? We know that P is equal to the charge of the unit of charge is what? Of course we know that it is coulomb, and 1 coulomb is equal to 1 ampere into second, right? And of course what is the unit of displacement? That is meter. So instead of writing the entire coulomb meter, I can write here cm, c dot, or like this, right? But this seems like centimeter, so it's good to write the entire word, coulomb into meter. This is the SI unit for the electric dipole. SI unit means System International. International. Wait, let me highlight this, then I'm going to tell you the non-physical unit for the electric dipole as well. Now the non-physical unit for the electrical dipole, right? Non-physical unit for electric dipole is state coulomb centimeter. State coulomb centimeter. This is the non-physical unit, right? This is the non-physical unit and is very important in terms of MCQs. Non-physical unit of electric dipole is, of course, state coulomb centimeter. In CGS system, in CGS, which means centimeter, which is of course the unit of length, right? Gram, which is of course the unit of mass, and second, which is the unit of time, right? In CGS system, unit of electric dipole is the unit of electric dipole is d by, right? So this is very important again. What is the unit of electric dipole in, CGS system? In CGS system, the unit of electric dipole is d by. Now you can be asked what 1 d by is equal to, right? So I'm writing here 1 d by is equal to 3.3 into 10 to the power into 10 to the power minus 30 coulomb meter. 1 d by is equal to how many coulomb meter? 1 d by is equal to 3.3 into 10 to the power minus 30 coulomb meter. Then you can be asked 1 state coulomb centimeter is equal to how many coulomb meter? 1 state coulomb centimeter is equal to how many coulomb meter? So that is 10 power minus 18. Let me write this again. 10 power minus 18 coulomb meter. Right? Wait, so let me highlight this. Okay. So 1 state coulomb centimeter is equal to 10 power minus 18 coulomb meter, right? So what we have discussed today is we have discussed about the units of the electric dipole. Initially I have told you another definition of the electric dipole, and that is a product of magnitude of opposite pair of charges and the displacement or the distance they are placed at, or the displacement between these two opposite pair of charges, right? So how can it be written in a mathematical form? Of course, q into displacement, and the unit of charge is coulomb and the unit of displacement is meter. So coulomb meter is the unit of electric dipole. SI unit of electric dipole is what? SI unit of electric dipole is of course coulomb meter. Then we have discussed about the non-physical unit of the that electric dipole, and that is of course state coulomb centimeter. In CGS system, the unit of electric dipole is d by. Then you can be asked 1 d by is equal to how many coulomb meter? then 1 dBi is equal to 3.3 into 10 to the power minus 30 coulomb meter. Then you can again be asked 1 state coulomb centimeter is equal to how many coulomb meter. Then your answer must be 1 state coulomb centimeter is equal to 10 power minus 18 coulomb meter. Here we have completed our this chapter, the electric field, right?